255, 255, 255, 255. What would the prefix length be for that? 32. So let's just plug in 32. So this is more or less, we're going to do like the table that we do. Okay, what would come after 255, 255, 255? Then it would be, what would the next one be? If it's a third, 254, right? So let's do that one. 255, 255, 254, 254. Yeah, yeah, download it, and I'll wait a minute while everyone downloads it. And then we'll be filling it out. And that way it'll be a nice reference. Yeah. So what's after, so then that would be a slash. So this one was a slash 32. And then what would the next one be? This one's a slash 31, right? Slash 31. All right, so we're going to fill all these out. 248. Do we agree? 248. And I'm going to cheat. I'm going to copy this. Control C. Yeah, and I'm going to like pop it in here because that's like what's changing, right? So from the 248, what's next? 240. What's next? 224. What's next? 192. What's next? 128. Oh, did I screw this up? What's after 128? I think I screwed this up. 1, 2, 3, 4, 5, 6, 7, 8. Okay, what's this one? Oh, I'm like, why is this not looking right? What have I done wrong? You're right, I missed 252. Look, don't copy my work, you'll get it wrong. Don't look at mine, you'll get it wrong. I was like, I could tell something wasn't right. Okay, 240, then we had 224. Now this looks much better. I'm like, okay, 192, 128. And then again, over here, we're just counting backwards, right? Slash 30, slash 29, slash 28. This is what we're used to, right? Slash 27, slash 26, slash 25. So just up to this point, what octet is this? Fourth. So put the fourth octet in there. All right, this is the fourth octet. All right, so then what's next? What's after the 255, 255, 255, 1.128? What do we need to do? Right, because we got to move, we're moving into the third octet with where our networks are going to be, right? So let's see. So for this one, I'm going to show you, I'm going to do this. I'm going to do, because I want to do the copy and paste, but I'm going to take this guy out. Because isn't the fourth octet always going to be 0? Yes, Andrea, the fourth octet will always be 0. Okay. So what's this one? 255, 255 dot. Okay. And then 252, and then 248, and then 240, and then 224, and then, and what do we notice about the positional values? They repeat in every octet. So like this is just another way for us to see that, right? It's another way for us to see that. And let's keep counting down. So again, remember the prefix length or the slash notation represents the number of what? The number of what?
Bits.
What kind of bits? Network bits. A specific network bit. It's a specific network bit. Okay, so then we're going to do /24, /23, /22, /21, /20, /19, /18, /17. If I keep going, /16, /15. Again, what octet would this be in? So this one right here, the one we just finished, that would be 3. And what would this one be? 2. So we'll just do a couple. We don't need to do them all. So it's going to be 255.255.0.0. Okay, then what? 255.254, because it's going to repeat, right? It's going to repeat. Okay, so for a minute, we're going to skip this. We're going to skip the number of networks, okay? We're just going to skip that for a minute. All right, and let's fill in the increment for the magic number. So if there was such a thing as a subnet mask, 255, what would the increment be? It would be 1. It would be 1, right? Because that's where the last network bit is. Okay, so what about this one ending in 254? 2. What about 252? And 248? And 240? And 224? And 192? And 128? 128, right? And so what do these numbers do? What are these increments going to do? They're going to repeat. So let's just pop that in here. They're going to repeat, right? 1, 2. They're going to repeat. So we're just plugging in all these things that we've been learning about, right? Just plugging these things in. So just get that plugged in. So where does the magic number come from? Where does that increment come from? It's where the last network bit lies, right? So if we're looking at this one, 254, right? First of all, what octet is it in? It's in the 4th octet, and if we bit out 254, it's right this, right? And we know that, what is this value? Right here? Call it out. And this one? 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 This one? Right? So here, that's where our last network bit is. So our value is 2. Our increment is 2. Right? Are we all on track? We're tracking with what we've been doing, right? We're just plugging these numbers into a little table. Okay, so the next thing is, let's look at the number of host bits. We're just looking at bits. Okay, we're looking at the host bits, not the total number of addresses, but we're looking at the bits. So first of all, right here, how many host bits are there? 0. There's 0 host bits. Okay, there are 0 host bits. Okay, so what about this one, 255, 255, 255, 254? 1 host bit. 252? 2 host bits. 248? 3, right? 240? 4. 224? 5, right? 192, 6. 128, 7. Okay, how about right here? What is the 255, 255, 255.0? 8 host bits. 255, 255, 254. 9, right? So we see these patterns. So let's plug that in, right? Plug everything in. 11, there's 12, there's 13, there's 14, 15, 16, 17. Okay. So I'm going to stop here while everybody gets caught up to this point, except Caesar, who came in late. Okay, good job. Yep, perfect. All right, so now the total addresses, again, let's just think about the math. And we did this again on Tuesday, but I wanted to just recap so that we, can bring it back to our first couple of weeks. So the math behind this is let's not do that one. Let's do this one. 2 raised to what? 1, right? 2 raised to the number of 1, which equals 2. And this one would be 2 raised to the number of host bits, which is 2 raised to the power of 2. Okay. And then 2 raised to the power of 3. What is it? 8. Okay. So I just want to make sure we know we're using this, right? 2 to the 4th, 16. 2 to the 5th, 32. 2 to the 6th, 64. 2 to the 7th, 128. Total addresses, right? Total addresses. So fill that out. And this is where we're just doubling, counting by binary, 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1. Really, we could never do a 255, 255, 255 because with just one address, you can't have a network and then another one, right? So it's not a real thing. We are going to use this in 150. We're going to use the 255, 255, 255, 255 for routing. So there is going to be a purpose for it, but it's going to be different than what we know. 2 to the 0 equals 1. Right? I'm already doing it wrong. 4. I can say it, but I can't type it fast. 16. Oh, I can just do this. Control C. 512, 1024, 2048, 4096, 8192, 16384, 32768, 65, 536, and let's see, something. Thank you. 131702? 072. Good job. 072. I still did it wrong. 072? Like that? 131072? Okay. All right. So far we're good. Are we good with all this? How we are coming up with these numbers and where they're all, how they all mix and match and how we use, right, the total number of bits to figure out how the total addresses are. So then what about usable addresses? What do you have to do? You have to subtract 2. Why do you have to subtract 2? Exactly. 1 for the network, 1 for the broadcast. So go ahead and fill in that column. All right, so then I just want to revisit the networks, okay? I just want to revisit the networks. This is what we had talked about on Tuesday, so let's just revisit this. And it's similar to figuring out the hosts with one little difference. What was the difference that we talked about? Raise your hand if you can share. What was that difference? Raise your hand, Matt. Okay, this.
Your question was, I don't know if I have the answer.
The subnet. Okay, so we talked about how to find host addresses, right? 2 raised to the power of host bits. On Tuesday, we kind of talked about, not kind of, we did. We talked about how to find the number of networks. The math is the same, but there's something that's a little bit different. Gabby? Yeah. So it's still 2 raised to the power, but we use the network bits in the octet that we end in, where the network bits end, okay? Right? So let's just take a look and see how we would do that. And it's just per octet. So here, like if we look at 255, right, we don't have any here. Okay, so well, actually we do, but there's no such thing. It would be 256. Okay, so 254, how many network bits do I have in the 4th octet? 7, right? 254, so here's our 254. 1, 2, 3, 4, 5, 6, 7. So the math would be 2 raised to the power of 7, which equals 128. So we'd be able to get 128 networks if our subnet mask was a /31. Okay, now what about this one? How many network bits do we have in the 4th octet? 6. So if we did 2 raised to the power of 6, how many networks could I get? 64. Okay. So now we're going to keep doing that, but let's jump down here to our 3rd octet and look at this one, okay? So let's just look at this. So what octet is our last network bit in for 255, 255, 255.0? 3. So how many network bits are in the 3rd octet? 8. So 2 raised to the power of 8 equals 256. 256. Okay, so again, the only difference is that we only look at the network bits in the octet. Okay, now, if I had to figure out a way to go outside of that, I can do that. But traditionally, this is what our limits would be. Okay, you'd have to work with the ISP if you were going to be doing something different. All right. So let's fill out all of these. Okay, so that's our last column. So in other words, if someone says to you, hey, I need 64 networks, okay? I need 64 networks, and I'm gonna, and they're really small networks. I only need like 2 hosts. Which subnet mask would take care of that? Exactly. Exactly, a /30, not a 31, a /30. Okay, see, sometimes you're figuring out your networks based on the number of hosts, but you might also have to be thinking about the number of networks that you need to build, right? Okay. All right, so filling this out. So this is, and I'm going to actually put the little math in there so that we can see that what the math is. Eight, 7, 6, 5, 4, 3, 2, 1. Where's my equal sign? Oh, I should have done the equal too. 256, 128, 64, 32, 16, 8, 4, 2. I'll copy again. Okay. Right, so again, what if I said, I need, let me look, let's see. I need 2 networks. So I need 2 networks that have at least 280 hosts. What would I use? So I need 2 networks with at least 280 hosts. Yeah, so you have to, yeah. See, it gets complicated, right? Because you might end up with more hosts than you actually need, right? If you're, depending upon what you're trying to do. So we said 2 networks, right? So we needed 2 networks, and what did I say for the hosts? 280. So 280. So if we needed a slash, so if we have slash, if we did 280 hosts, so that would put us, like a slash 23 is what we would do. Or you could go down here and you could do like a slash 19, but then you're wasting so much more hosts. You're wasting so many more hosts. So there's like this whole little math that you've got to figure out. Like, is it better to waste hosts? Better to get the right number of networks? So you might end up with a few more networks, which is fine, because if your company grows, you may be able to use those as extra, right? So there's a couple of ways that you have to think about these different things, right? Okay, does everybody have their chart filled out? Okay. So you might want to save this for yourself. Okay, so save it, and then I'm going to come around and take a look at it. Make sure you got it all filled out, and then you can mark it and that we did it in class. So go ahead and mark that we did it in class. And I want you to, again, save this and study from it and keep practicing the binary, okay? Keep practicing your binary. And we're going to do a Kahoot around that chart. Keep it open. Okay. It's like, all right, ready? So this is how many networks can you get from a particular subnet mask, okay? Ooh, a /9. What happened there? So let's see, if we look at a /9, what octet are we in? Second, so it would be 8 in the first one, 9, right? So we have 1, right? So 2 raised to the power of 1, 2. Yeah, and like, let's look at it. 192.168.0.0/17. So I'm putting us in the third octet just to make it a little cleaner. So there's one address, right? Now what if I increment that? What would the next network be? So here's the first network address. What would the second network address be? 128.0/17. Okay, so now what if I increment it again? It moves us into this octet, right? So really, a 17 and this, we can get 2 networks from that before we have to move, right? And the goal is not to move, right? See that? Okay. If we could do it with we could do it with an 18. If we did this with an 18, let's do an 18. So if this were 18, what would my increment be if this were an 18? 64. So I'd have how many network bits? 2 network bits. So 2 raised to the power of 2 equals 4. So I should be able to get 4 networks from this, right? 4 networks. So 18 increments by 64. So my next network is 192.168.64.0. What would the third network be? 64 plus 64, 128.0/18. What would the fourth one be? What would the next one be? 128 plus 64, 192. 192.0/18. How many networks did I get before I had to move into the next octet? 4. And that's what we said we'd be able to get, right? 2 raised to the power of 2. Okay, understand that? I want to make sure, because people look a little like, I'm not into this.
Is this also what they were going for with the 4-question or 4-answer questions where this network and
Yes.
this subnet with this many
Yes.
networks and hosts?
Yes, yes.
I struggled with that one.
Yeah, we did that one in class. That's one we did in class. Yeah.
I still struggled with
Yeah, and that's why we're doing it again, because again, I get it. It's different than what we did with hosts, but that is what they're getting at. Yep. Okay. How many network bits are we dealing with? For a 27, how many network bits? Okay, somebody other than Jason answer. And somebody other than Matt. Thank you, Brody. 3. So 2 to the power of 3. 8. 8. Yeah. Two raised to what power? 8. 8.
Just weird going back and forth. I think that's what's messing me up.
It is, but you got to do it. Like you got to train your brain to do it. Yeah, agreed. It is. It's hard to always keep it straight. That's why we call this class brain training. Oh, sorry. What did I push? Did I push the number? Okay, there we go. All right. A little better? Gabby, nicely done. Marcus, outstanding. Orgil, good job. Good job, everybody. Matt, Brody, runners up. Nicely done. Go ahead and go mark that we did that one. It's not published? Let me see. Can you refresh your screen, Matt?
It's not doing anything unless I already did it. I already say it. I only see class activity unless you don't have dated.
Oh, I might not have it dated. Let's see. How many networks in 20 seconds? Oh, yeah, it's got yesterday's date on it. Hold on. That's why you're not seeing it. 8. 8. Okay, let's see. Save. Okay, now try refreshing it. I think you might see it now. Okay, did everybody bring their flashcards? No, because you didn't do them, or because you didn't bring them?
I forgot them in my back. Well, they're in my backpack, but I forgot my backpack. So I just need to get here.
But did you already get them graded?
Yeah.
Okay.
Tuesday.
Okay. How about Lou, Ozzy, Joey, flashcards? But I did say to bring them on Thursday. Angel, flashcards? Flashcards. Thank you. How about over here? Flashcards, flashcards. Okay, so we will put Marcus and Angel Jason together. Okay, Marcus and Jason, and the two of you just talk about your flashcards. Okay? Talk about your flashcard. Don't get the wrong idea. Don't get any ideas. I'm happy to give zeros. Retroactively. Okay, wait. No. I have a new idea. Just thank you for giving me this idea, class. Because Jason and Marcus didn't bring their flashcards today, all of us will ask them one question. And you can take class for that. Okay, we're still going to get into groups. Let's see. Okay, Ozzy and Daniel, Guillermo and Caesar. That comes out of there. Change group. Okay, Angel and Matt. And let's see, Brody and Joey. Orgil and Gabby. And let's see. Lou, join Brody and Joey. Did I get everybody? Yes. I got everybody. Okay. And then Jason and Marcus. And I'll come around and collect a card from everybody so that I can quiz Jason and Marcus.
Your one first, or?
Yeah. I'm not remembering.
Okay.
We just turn it in after
The easiest one,
after
for the
the
supporting
upgrade.
host
Yeah.
And then also for the
No problem.
for the mind map, I'm not able to turn them in when I'm at home. For
And
some
then
reason,
what,
whenever I
okay,
try
so
to
what
share them,
is the
it gives
of
me
copper?
a message about not being able to share
Which one
them.
is it? Remember we got the UTP, the SGP.
Card sharing is unavailable at the time.
Okay, before you leave today, let me show you another way to try sharing.
Yeah, that's
Okay.
cable or copper.
Like I'll show you in here, and then you can try it at home. Did it work the way I told you to do it?
I think it did, as long as you were able to, like, we saw it, right? That it
Yeah.
still came up, so the way that you showed me also.
Okay. Are you in a folder?
Actually, I might not be.
Because that's the other way. If you don't put it in a folder, it doesn't always share. So if you go look at the initial instructions, it tells you to build a folder and share the folder. So you might have to do that. It's a little weird, but we'll figure it out.
I definitely have a folder for it, though. I know that.
But maybe you didn't put it in the folder or share the folder. You have to do both. You have to put it in the folder and share the folder.
I also had ones on,
Is that Beetlejuice?
what's that?
Is that Beetlejuice?
No, it's Lebowski.
Oh, okay. For a second, it looked like Beetlejuice.
I used to look like this when I had hair. It was long.
The Big Lebowski. Is it the Big Lebowski? Yeah.
He was just
Lebowski, the dude, yeah.
big
The other one.
executive.
Yeah. You know they're coming out with a new Beetlejuice. They are do you know who's playing Beetlejuice?
I thought it was going to be.
Yeah, I just heard there's another Beetlejuice.
Yeah, I thought it would be disappointing if it wasn't.
It would be.
I mean,
You did it really well.
Although Jared Leto might be able to pull that off.
in some levels, I think he's overhyped. I did like him in a lot of stuff.
Yeah.
You know, like he was good in Requiem for a Dream. I didn't
Dallas
like him in the
Buyers
Suicide
Club.
Squad, but yeah, that one.
I loved him in Dallas. Yeah. I don't remember Suicide Squad.
He was the Joker.
Oh, I hated that movie. I just didn't like the movie. It just wasn't that good. Okay, enough talk about the movies. This is punishment for not bringing your cards. What is signaling? Okay, let's see if we could, okay, you're on the right track. So, say that again, how you send data? So what are the 3 different ways of sending data? When we're talking about the physical layer.
Light,
Yes?
what was copper's?
Don't tell him.
It's the amount of, how much data you transfer. Do not remember the other two. I remember the light one because I thought that was really interesting. Like the class.
Well, when you have just a computer plugged in like we have it here, how's it plugged in? What would that media be?
The copper cable.
Copper. Yeah, so copper, right? So we have fiber optic light, we have copper. So what does copper use? So fiber optic uses light, pulses of electricity, right? Then what's the next one? Nope. So coax falls under copper. No. What are the different ways that you would access the internet or the network? Wireless. So those are the 3 ways, right? Now each of those have a signal, right? Because the question was, what is signaling, right? So fiber optic, what is it used to signal a 1 or a 0? Exactly, that's it. That's how it signals. So that's what signaling is. It's using a light to signal. What does wireless use? Radio waves, sound waves, radio waves. And then what does copper use? Yeah, so that's the signal. Electricity is the signal, okay? And then what's another component of signaling that's important?
Is the rules to the conversation, things like timing and error checking.
Exactly. So timing, right? That's where you have to, the physical layer, with the help of the data link layer, but more the physical layer, it sets a time for, I'm going to use light as an example because that's kind of the easiest one. So it'll say like 3 milliseconds. If the light is on for 3 milliseconds, that represents a 1. If the light is off for 3 milliseconds, that represents a 0, right? 1 and a 0. That's the signaling. So what if the light's on for 6 milliseconds? How many 1s do you have? 2. So what if you're trying to do 192? That would be 6 milliseconds on, and 3 times 6, 18 milliseconds off. Make sense? So that's signaling. That's signaling.
And that's where you get into for example, there's different signaling protocols.
Yes, you're right.
But for even
like ATM.
Right, but still the Ethernet frame works across all of them, right?
Exactly.
Okay.
It works
and
across.
Primarily what we focus on.
Yeah, we're just looking at the basics. So like when we talk about the data link layer, the frame, we're going to be looking at the Ethernet frame, and it will have the control in there, and that will the control is helping the media. And then the type is helping the network layer. So that's where all that information would be inside the data link layer. So the data link layer is actually going to be communicating with the physical layer and vice versa. The physical layer with the data link layer. Okay, so.
That was some of mine, and the different. What was one of the ones?
So what's
I think
the?
I had cards on encoding encapsulation. So that was what some of my cards are.
So what speed does Cat 7 run at? No. Cat 7.
The minimum for the 10G?
Is it?
I want to say it's 10 gig.
It's 10 gig. What's the other category that can go 10 gig? 6A. There's actually no such thing as a 6E. So there's a 5 and a 5E. There's a 6 and a 6A. So 6A and 7 can go 10 gigs. What does 6 go?
6 is what? 100.
Well, if 6A is 10,000 gig, what 6 is?
I don't remember how steep it dropped. Was it a factor of 10 or a factor of 100? That's
Yeah.
when I went to downhill. That's all the way down to 5.
What does a T568A cable start with? T568A.
Like orange, white stripe.
Is that an A or is that a B?
I honestly don't know.
T568B starts with orange. T568B starts with orange. T568A starts with green, the white green.
Yeah, I never had to wire the jacks.
Oh,
Cables.
yeah.
So,
Okay. You keep asking. I'm going to collect a question from every team. Can I have a question from your team?
Let's try to find who has the hardest.
Do you want to do the encoding one?
Which one was the? Oh yeah, let's do the encoding. I like that.
What is Manchester encoding?
Yeah, what is? Let's do that one.
Is that ATM?
It's the. What is it? It's the. It has a whole.
Is it for telecom?
No, it's just for doing bits. It's.
It's like the way it's encoded, so there's like a max and a min, I think, like the way the voltage works.
Oh my gosh, I
We have
don't.
like a full page on it in here.
Oh, I feel like I need to go read that. I forgot.
So just over.
Let's see.
I made sure to make a note card on it.
Yeah.
Just in case.
That was like, that's a good note card right there. Oh, what is NIC? NIC.
Yeah.
Interface card. What is Ethernet? I don't know why. That kind of like threw me off. What is Ethernet? No. These standards.
Yeah, it's just the standard.
It's a standard, yeah.
Communication standard.
It's a communication standard for copper cabling. Well, not even just copper, actually.
It's layer 2 and 1 communication standard.
No, it's actually just a protocol. It's like so Ethernet is a standard for media. So it's like it's for the way media has to be like built or created or invented so that you can plug in devices. So you have a standard. Yep. So let's say I'm going to build a cable, right? And I have come up with some new invention for building a cable that can connect computers. I still have to make sure that it will Ethernet standards, because I can't force like everyone, hey, you got to go buy a new computer or you got to buy a new port. I have to meet a standard so that it matches all of the other standards, and that's what Ethernet is.
Right, so Ethernet is one port with two different meanings. Like one is a standard and one is a cable. Right?
I think the cable is more like a colloquial term.
Exactly.
Kind of like just like slang.
Exactly. Exactly.
Associate what ether is with what other.
So if you say Ethernet cable, that means that cable meets Ethernet standards.
Oh, okay.
Right? Yeah. So this is but it's on a mouse, so it's not, it doesn't meet Ethernet standards because we wouldn't use this type of a cable to connect computers or connect networks.
You're liking the plan full.
So, yeah.
It's like the same thing.
Does that make more sense?
So it's supposed, like, if you make a cable that's supposed to fit into Ethernet, it has to fit standard.
Yep,
You can't make a USB-C and call it.
I would agree with that.
right. Exactly, yeah. Okay, do we have a question?
What is Manchester encoding?
Okay,
A method of encoding that represents high to low.
put your name on there, Joey.
Yeah, that's a good question. I'm gonna do highly specific ones like that next time. Are questions like that, would those be on the CCNA, you think, or?
There will, I hope a question like that one isn't, but yes.
Okay.
Yeah, but again, it will not be this easy. It won't say, the question won't be what is Manchester encoding and then give you multiple choice. It will say something like, let me see that again.
Like the encoding method using.
Exactly.
type
It'll
of
say
things?
something like, if you see a pattern like this that represents a high to a low voltage transition with a 0 bit, what would that be? What would that be? So first of all, you have to know that that would be a type of encoding for starters. Then you would have to know that it's the Manchester encoding. So every question they ask, you have to know something about something to answer that question. Like, first of all, they want to know, do you even know what we're talking about? So if you can get in the area, because then they'll give you something like, oh, that's the network layer standard of sending a packet. Well, that's totally not related at all to the layer 1. So you have to at least know, like, okay, that's the word encoding. That's related to layer 1, so now what do I know about that? And then you get it. So you might be able to, get rid of a couple of the answers by process of elimination because they won't relate to the layer, but you have to know the layers. What if you don't know the layers? Well, then you're like, well, I'm a goofball. Okay. Your first question from the class. And I didn't know the answer to this question. Oh, am I showing you the answers? What is Manchester encoding?
Manchester encoding.
It's a form of encoding.
With a British accent.
Manchester. I sound more like Chester the cat. Okay.
I imagine it's something to do with the rule set of how it encodes.
It does.
After Manchester, I have no clue.
So it is a method of encoding. So that is good. That represents a high to low voltage transition as a 0. So high to low, so it's setting that high to low, and low to high as 1. So it's talking about Ethernet, so it would be on Ethernet. It would probably be on electrical. I don't think that would be wavelength, but I think this is probably a method
Yeah, it would be specifically
for
applied to electric.
cable. Do you know for this Manchester, was it just for Ethernet? Like just on copper cabling? Oh. Oh, yeah. So I think this would be more electrical.
Yeah, it would have to be strictly electrical if it's voltage up and down.
That's what I think too.
I mean-
Yeah, because it's voltage. Oh, because it's voltage. It has to be electrical. Okay. 10 megabits. 10 meg. That's not very fast.
Data, sorry.
So 10 megabits. That's like so slow. So that's probably actually a legacy encoding method.
Makes sense how the name.
All right, how are we doing over here?
I think we're doing pretty good. What is crosstalk?
I know it's the organization. Like the IEE.
Yeah, basically it's talking about certain service caused by electrical or magnetic fields.
What could cause crosstalk?
International. Is it international?
Like Bluetooth?
No. I don't think so.
Well, isn't that what?
Crosstalk is going to be more probably on copper.
Isn't that the same thing as on an airplane? Like why they have you stow away your stuff, so there's no interference?
No, I don't think so. That's different. That's a different kind of interference, I think. Again, I'm not exactly certain.
So what's the answer you're saying?
So what is crosstalk? What's something that can cause it? If wires are cut or damaged, that could cause it or damaged. So if you think about like the copper cables, and you know how they're twisted? So for one thing, if those get untwisted, that can cause more crosstalk because the message will bleed through, it'll cross over. Even with the sheathing, like the little sheathing, that's why they twist those wires to eliminate that. Also water, if water gets inside your cable and moisture gets in there, that water can cause the electrical signals to cross over and you can get crosstalk. If you have a cable and you lay it across another cable and the sheathing isn't really good, that can cause crosstalk.
So
Yeah.
basically all cable related?
Yeah, I think I
Is
really,
there anything that's not cable related?
well, I mean, wireless you can have problems, but like EMI and RFI is specific to copper. EMI, like you don't get any EMI or RFI on fiber.
Yeah, we were just talking about that.
And you don't get EMI or RFI on wireless, but again, wireless has its own types of issues, but just not crosstalk. So what you're thinking of on wireless, that's more from dropped signals or from the type of interference that is that's called collisions. So the way that wireless works is they run on half duplex, so it can only go one direction at a time. Well, let's say you're talking, and the timing, so wireless has a timing component. If the timing wasn't just right, those conversations hit each other. And then it's, like, I can't, that's because they're having a collision. And then eventually one of them has to drop or stop, right? Like you stop talking. If you stop talking, then this signal that got interrupted can at least finish, even if you don't hear anything, and then the next one can go, because wireless is half duplex. Copper is full duplex, so they can go like this, but wireless can't. And when we talk about fiber optic today, really, fiber optic is very interesting because it's half duplex, which means it can only go one direction at a time, but they make full duplex or double duplex fiber cables. So there's two of them that one can go, so they can cross and still go at the same time. And fiber is so fast that
What would be the
it can
point
go.
of having a full duplex fiber? Because don't you need a half duplex to get the connection itself? Or?
Nope, you want to have full duplex so you can send and receive at the same time.
Also download, upload.
Yes, and that's why copper is efficient, because you can do both. And with the new switches, you have full duplex, so you can send and receive at the same time.
Then you wouldn't have fiber.
Huh?
But then you wouldn't have fiber.
This is true. I don't know. Fiber is really evolved more from a speed perspective. It has nothing to do with, like, it wasn't created for full duplex. It was created for speed and for efficiency.
I'm not even, I said my old house was fiber, but this house I've been in for the last 3 years is not anymore.
Oh, it's a bummer.
I was telling you about DSL. So if you're talking to someone who connect to the phone lines that are actually
Yeah, they are phone lines. DSL is a phone line.
phone lines are complicated, right?
Most of them are, yeah. So that's a digital subscriber line. With DSL, they break it into a B and a D channel, a data channel. And the data channel can go at much higher speeds, as long as you're within a certain distance to the central office. Within 300 meters, I think. Yeah. I mean, that's how you get the best DSL. But then they have repeaters. So the way a repeater works is, even if you're not really close, it'll hit the closest repeater station. And what the repeater does is it takes the DSL signal and it bundles it up like this, and then it makes it super tight and then it pushes it out again.
And then isn't that also how we like our project in Hawaii? Yeah, they're gonna
That's probably fiber optic. That's going to be long haul fiber optic cable. No, they have to have repeaters. So there's a bunch of repeaters in the ocean. Yeah, even for fiber optic, you have to have repeaters after.
Yeah, so it was only
10
a little under 2 miles.
Yeah, yeah. So you have to have a lot of repeaters. So they'll have laser repeaters under the ocean. Have you ever looked at that?
No,
Oh, I'll see if I can pull up a picture.
that's pretty cool.
Yeah, it's crazy.
Probably just a bunch of little dots everywhere in the ocean.
Oh, they're massive cables under the ocean.
Really?
Oh, massive. Yeah. Oh my God. Yeah, it's so crazy. All right, everyone ask one more good question. One more good question. Do you have a good question that I can ask my, do you have a good question I can ask my group over here?
I like the answer as I do. So I gave him one of the
Oh, yeah, that might be a good one. What's the Ethernet standard? 802 dot?
Ethernet standard?
Uh-huh.
It's this one right here.
Dot 3.
Oh, what? What is? I thought this one was it.
Oh, what is the, hold on, no, that's not, that's a wireless one. What does it say? 802.15, I think, is that Zigbee? What is it?
It's the low power and or low data rate.
Low, what is that used for? Low power, what is that word? Or
/and data rate.
I have no,
Neticat said.
huh,
I think it did say Zigbee.
what's that one? 802 dot, okay, that one's Bluetooth. Jason might know that one, we'll see. Yeah, oh, so 802, yeah, that one. Find Zigbee. Okay. What is the standard for Bluetooth? No. That's wireless. And Bluetooth is wireless, but that's more for wireless, like phones, Wi-Fi. Yes, thank you. The Wi-Fi standard. So this is a different standard.
Well, it was developed by Arabs. Named after Arab Bluetooth.
We know it's not 802.11. It is an 802. Yeah, because it's wireless, so it's going to be an 802.
Is it 13?
No,
What is it?
no. I've never heard of an 802.7. There is an 802.7, but it's not one that we study. So, for example, all these wireless cars, all these driverless cars, they have an 802 standard because they're working at the physical layer and the data link layer. They're working at layer 2. 802.15. I've never heard of that.
Never heard of that? About the,
No.
yeah, where people go up, they'll hijack the signal. From
And they can steal like a
Well,
a driverless car.
What they're doing is they're enhancing the signal of the fob that's
Oh,
inside the house.
yes.
They'll trick the back.
Okay.
they'll literally walk out and they'll like unfold their arms with like cabling like right here, and it turns them into like a big antenna.
So my next door neighbor's car was stolen a couple weeks ago. They have a Kia and they have, I guess, a fob, or something like that. And then somebody broke into my car a few years ago with a fob, and they moved all my stuff around. They didn't steal my car. They didn't. And I had my fob in the house, and right after that I started putting it in a Faraday bag. And then they did the same thing to a bunch of us on my street, my mom's car. And when I opened the car, I was like, I feel like something's different here. But I was like, and then my mom was like, somebody was in my car, and I was like, someone was in my. That's what it was. It's like everything was moved, I was like,
so blind to getting into it every day. It's just like you don't even realize.
I was just like, what is going on? I was like, I didn't leave that there, did I?
It used to not be that big of an issue, but now they can even reprogram the fob onto your car with
Oh.
this little thing. They're doing that a lot with Range Rovers.
Let's see.
I live out by like a retirement community and stuff. They get really old. They post I think it was like 2 videos that they posted of they're doing that thing.
I'm gonna go look.
Like some people will just be blatant about it. They'll get out of a car, come out with like an antenna.
Let's see.
Yeah, there's no moving that again.
What did you say that? Oh, you're looking at
All right, so here, this is the undersea cable. Yeah, the public ones, correct. Right, these are the ones that we know about, okay? I mean, this is how countries are communicating, right? This is how countries are communicating. Do you remember when the tsunami was in the Pacific? Even the one even before, the one that caused the Japan tsunami.
Yeah, that earthquake.
Yeah, 2003.
It was a while ago. I mean, that took out all the fiber. Let's see.
I remember when it was a big deal, was it Sprinter MCI was doing the first one with AT&T.
Yeah, that's one question I was gonna ask is how does this make sense to do it like this and an earthquake would just rip up the entire thing?
Well, there's redundancy. So,
Unless they figure out a way to not make it stick.
no, a lot of this is redundancy. So, like, they'll have something going to a country. If it breaks, they've got a redundant loop going another direction. But yeah, I mean, it could be a real problem, believe me. I wanted to see if we could find an actual picture of some of it.
And believe it or not, all of your telecommunications
There we go.
process through
So see that?
May East and May West.
Those are the cables the size of us or something.
They're,
Cabling is massive.
it's massive. It's massive.
Bundles of cable.
Yeah.
I mean, you think a
So,
25 pair of copper wire is about as thickness of your index finger. 25 pair of fiber has got to be like the size of your wrist.
so do you remember I was saying about the repeater where it will pull up? So it'll send out the signal and then it's got to have a repeater where it takes the signal and it bundles it up and so that it can push it back out with a laser. And they'll have several of these, you know, across the ocean, these repeaters.
Soon that would cause latency issues, right?
See issues?
Latency.
It is what you see.
Yeah. Yeah, but it's still, I mean, if you think about from here to Japan, from here to Australia, it's still amazing how fast we can, you know, I mean, it's crazy. It's incredible. Let's see. Close. I was just going to see if I could find a good picture.
I mean, so much so that you don't even experience it.
Oh, there's a nice picture. Yeah. So that's the fiber optic. It's mostly fiber under there. Mostly fiber. I'm sure there might still be some copper wiring in the ocean. I mean, that's what it was before. It was all copper, you know, protected in what's called a jelly cable. So it's like all this gooey stuff, you know. All right, let's take a break. All right, it's 7:23. Let's take a break and be back at 7:30. 7:30. I saw it. We just haven't graded it yet. Did you submit it late? No. Oh. Okay, we'll take care of it. I did see it today, though. Okay. Yeah, we'll take care of it.
I don't recall that in the logic. So. That was quite the question. See, I don't know. Are you a gamer? Have you ever played a game in an overseas
I like skin
pool and
Like Europe,
experienced serious lag?
No, not serious lag. There's a competitive edge.
But you definitely notice a difference.
Oh, just you get like,
That's the way
once
he
you get it, you get like connect, like the cabling and both sides, like yeah, I struggled through that so hard. If you're gonna do it, have everything up right there. You only have like 1 minute to do it. So I already have everything because I had to bring everything up. And that's why he was okay. Like, so we have it up. I didn't know what he asked me that hard.
had already, you know, it's going.
I know soldering. I've done that plenty of times. I don't know how to like welding, but that's hard. I somehow managed to get like a free asset from like one of the method network places. But they all they do is make like a full like big old computers and like yeah. I was just learning the software that was like think about this the same. It's dying hard nowadays. This one is like crazy. All of these like systems like fire like next to each other. This is not the whole map. The whole map. I think there's like 3,500 systems. The whole one. I was glad I was in high school and going up and stuff like trying to get to the workforce. I think I showed you something. I was a sophomore.
Serenity?
The best part was the very first semester after COVID. It was like, yeah, we can't lower your grades, so just like do the assignments you want to do, which was nice. So I got quite a few free passes at classes I shouldn't have passed. like the math class I was in at the time, which I had to take in college anyway. I didn't take like 6 semesters again.
Try to remember all of them. It's like I don't use
It is a big neutral whatever. That was my last math class I ever took until college.
So you can literally
It's like, how are people like, oh yeah, how that's a thing I have to do.
I mean, if it's just twos, it's pretty easy.
Yeah, or like, I mean, like 16 or
Times up pretty easy. Like even add correct zeros.
yeah.
up here you can see
Still, it's like
soft changes in the day. Yes, up here as well. You can test the lines that are
Any math class, that's pretty much
That's my whole life. That's always the thing. Kids are like,
Because what ended up happening is
I'm like, yeah.
this entire pathway.
I'm like, you know how to read? Yeah. I don't like, you know how to add numbers. You're close. You're working.
remember Walmart. They're like, you come in at this time for an interview. I come in like a full suit. They were like, yeah. I'm like, whatever. They didn't even ask me questions. It's like, I thought, oh, okay, good. Good to go. Well, fine. Why do I have to like drive here? Wait for 30 minutes. Come back here.
Okay, you're hired. How long is it? Never even brought me to that place until like the first day of the
I didn't have to do an interview for my current job either. That's also because they're like, hey, we need someone else to work. And I'm like, I would say it was at Christmas or something.
this
I think I know the one you're talking about.
Yeah, it was REI.
What?
REI, that place is really relaxed to work.
Really?
Yeah, they give you like,
Right after I said, don't leave the cables over here. Hi. All right, so let's talk about Module 4. What layer are we working with? What layer? Module 4, physical layer, right? The physical layer. What do we call it if it's the TCP/IP? Network access. Yeah, it's the network access layer. Did somebody have their flashcards that they needed graded? Okay. Do you have time to do these? Okay. All right, so we're going to go through a couple of things as it relates to the physical layer, also called the network access layer. This is way in here. Throw out, what are some of the other characteristics that we need to know about as it relates to the physical layer? Didn't you all just answer a bunch of flashcard questions?
I don't think I understand the question.
Just throw out some stuff you know about the physical layer.
It's where the physical connections happen, obviously.
Okay. Obviously, agreed.
UTP is the most used copper cable.
UTP is the most used copper cable, agreed.
I think it's the most used cable in general.
For sure. For sure. I mean, and will fiber optic overtake it?
Potentially, if it gets cheaper.
If it gets cheaper, right? It's got to get cheaper, though. I don't know that it's hard to say because just copper is so inexpensive. Yeah. So it's hard to say. And there's so much of it, right? There's so much of it. Okay, what else? What?
That's what we mine here.
Yes, exactly, exactly. What else? Yeah, there's different cabling standards. Like, what's one of the cabling standards? Which is?
Oh, the straight through is T568.
Is it?
Yes.
Well,
Something like that.
It's the ends of the cable.
it's the ends of the T568A is a standard that describes the way that the cables are laid out, the wires are laid out. And T568B describes the way that the wires are laid out, right? So T568A, what does it start with, Gabby? White, green, right? White, green. And what does a B start with? Orange, white, right? Orange, white. And then what if I have an A and a B? What have I got? I have a crossover. I have a crossover. And what if I have an A and an A? And what if I have a B and a B? Straight through. Okay? And when do I use straight through cables? Dissimilar devices? Dissimilar devices? Yeah, so you almost have to think of it that way, right? Because straight through is two different devices. And a crossover, they have different ends, but they're connecting the same or similar devices, right? Okay, so I think on Tuesday we talked about like an exception. It's not really an exception, it's more just understanding the way the encoding works in the NIC cards. So if I connect a computer to a router, what would I use? Yeah, use a crossover. Because remember, they have different brain, the same type of brain. They think the same, right? They encode information the same way. So you are going to use a crossover cable if you connect a router to a computer.
Did our packet say otherwise?
There is a video that says otherwise.
I mean, like our lab packet, I think it told us to use straight through. Could be wrong about that.
I'm not sure. I'm not sure about that. I don't know, but definitely there was a video that said that. And again, there's a lot of it will work.
Yeah.
Mm-hmm.
There,
I had to change
there
it
was
to a
the,
straight.
there was the,
Something like that. I mean,
yeah, are you talking about that forward thing that slapped the back of the router and connected PCs to?
And it wanted a straight through to get the points. Yeah. Again, a straight through will work because of auto MDIX.
oh God, if it doesn't.
It probably won't. Yeah, it might not. What's auto MDIX? Exactly, it's auto sensing. So even if it's wrong, it can make a change so that everything will work. Okay, so that everything will work. All right, so we're going to go through a little bit of this. All right, so what's encoding? What is encoding? Somebody raise their hand and explain encoding. Somebody other than Matt. Only because you're answering a lot, Matt. I appreciate it. Thank you very much. If I had a pet, it might be you.
Oh.
Caesar.
I was going to say, encoding has to do with the way that the data is delivered, I think, if I remember correctly.
Not exactly. No, I mean, you're on the right track. And I meant that. Okay, and what does that mean?
Well, so it depends on what kind of signaling you're using, right? So it would be like,
Mm-hmm.
if you're using, what medium you're using. If you're using copper, it might be like electrical pulses.
Okay, so what is getting encoded? That's what I want to hear. The bits are getting encoded. The bits are getting encoded. Ones and zeros need to get coded to be in a format that the media can understand. Again, if you think about a copper cable, can a copper understand the number 1 or the number 0? No, but it can understand if the electricity is turned on, if the electricity is turned off. And as we were talking earlier, there's different types of encoding that actually describe the exact thing that the media is looking for. Like if it's a low to high voltage, or if it's a high to low voltage, which one represents a 1, right? And that's how that works together with signaling, too. That works together with signaling. And de-encoding is when you're taking it up off the media. So if you have light, then you've got to take the light signals and you have to turn those back into 1s and 0s, right? And then there's also a timing mechanism, so that we've talked about. Can someone describe the timing mechanism? Orgil? I see it. Not exactly flow control, no. The timing. The timing goes along with signaling. Marcus? Timing? We talked about it, right? A long time. Over here.
Isn't that like the timing between changes to the stack of tickets to 1 or 0?
Okay, yeah. Can you explain more?
Like an example would be like, if there's electricity going through it, it would be like a 1 for 3 milliseconds. Or if there's nothing going through 3 milliseconds, that'd be 0.
Right. Yeah, so that's part of the signaling too. So you have to set, the physical layer has to set a specific time that represents the 1 and represents the 0. So again, if we're using electricity or fiber optic with light on, so there'll be a timing that'll say, okay, if you see that the light or the electricity is on for 3 milliseconds, we're going to call that a 1. right? And so then what if you see it on for 6 milliseconds? How many ones is that? 2. So you have a 1, 1. And then what if you have the off for 18 milliseconds? How many zeros do you have? 6. So what would that be? So we had 1, 1, 0, 0, 0, 0, 0, 0. What is this? And what is the value? It's 192. Okay? All right, see how that works? Okay. All right. What's STP and UTP? We've talked about that. So what does STP stand for? Let's start with that. Shielded twisted pair. Shielded twisted. Oh, I wonder if I have a piece of shielded twisted pair. I hate shielded twisted pair because it's very difficult to work with. What? Yeah. Well, and I've been trying to make a Cat 6 cable for my house, and it is shielded and it has a center post. I have no idea how to make it. I cannot figure out how, so it's got like a plastic core to make it stiffer, and I cannot figure out how to cut the core out without cutting the cable. Do you know how to do it, Chase? Because you got to get down into the sheath, because when I pull the RJ45 on, the RJ45 doesn't go down. I can't figure it out. Well, there are crimpers, but you got to get the RJ45 over the sheath. I can do it, but then the wires are exposed. Anyway, and I'm good at making cables. I'm pretty good at making cables. So I was seeing if I had I thought I had, oh, look at that. There's a monster right there. Okay, so we can see the shield, and there's the center post. There's a center post in there, so I'll pass it around. So this is the shielded twisted pair. Really, it's a better product. The only reason it's uncommon and unpopular is because it's so difficult to work with. So, it's just very hard to make. It's very hard to make cables. Along with this, what are some of the categories of cables that we would need to know? Cat 3, which, do we use it? What's that? Well, you don't use 3, you don't use 5, but I think you still need to know 5E because there's so much of it. I have noticed, the phone, Lumen, whenever they're installing like DSL and all that, they are using Cat 6 now. However, all of your homes, most of them all have Cat 5E in them. Businesses, Cat 5E. So it is important that we know. So what's the speed for Cat 5E?
No, that one was 100. That one was
100 megabyte. Yeah, 100 megabits per second. But Cat 6 is, what's Cat 6? 1 gig. 5E. I think it's 100 megabits. Do you have it? Pull it up. It's in the book. Let's not get it wrong. Let's not do it. 1,000 megabits per second.
Yeah, that would be a gigabit.
Oh, and exactly. So it's is that what we said?
No, we said 100.
So I think it's safe to say that 5E goes up to the mix, but you said it wasn't recommended, like that we could push it through it, but that wasn't recommended.
Okay, so here, let's pull it up so that we're not getting it wrong. I don't want to teach the wrong thing.
But technically, if you have gig internet, you shouldn't be using 5E anyway. You should
There.
be using Cat 6.
Okay, so here it is, so that we don't mess it up, right? Cat 5 is 100 megabits, slow. It can support up to 1,000, but it's not going to do very good. Cat 5e, 1,000 megabits. Okay, that's what we want to do. Cat 6, again, far more common now. Added separator is between each pair of wires, allowing it to function at a higher speed. Yeah, see, this is what I've got. See that center post? That's what I'm having trouble with. I can't even find it on, I can't even find a YouTube video on it. It functions at a higher speed, can support 1,000 megabits. If you have Cat 6A, you can do 10 gigabits, but it has to be a 6A. Has to be a 6A. And then Cat 7, 10,000 gigabits. And then we have a Cat 8 now, which is 40. No, NASA's internet is called the bundle protocol. It's incredibly slow.
Is it?
Yes, so when you are doing interplanetary connections, it's very slow. It's very slow. It's called the bundle protocol. If we have time, we'll talk about it. All right. Yeah, if you have relatives on Mars, it's going to take a long time.
Well, think about the speed of light in principle. Think of how fast that is.
Right. Well, and so the bundle, okay, so let me think how I can explain this. I went to a whole thing on this. Earth, Mars, whatever, right? So they have to time, and then let's say you have a satellite out here, okay? You have to time the data so that it goes with the Earth and it bypasses getting interrupted by the rotation of the Earth, hitting a planet and having it stop the signal. So it's a very complicated, thing of having it being able to move around the planets. And so it's slow, first of all, because it has to go so far, like you said, the speed of light. But then they also have to figure out how to avoid hitting a planet and having that signal get stopped.
Well, it's not just the speed of light, it's the speed of light on a planetary scale. Because that's the speed of light goes from here to the moon is still a couple seconds. Or maybe remember, more than 1 second.
Yeah.
The speed of light. So look at Mars and stuff like that. It's even slower.
Yes. Yeah, it's very interesting. There's a lot of interesting stuff happening with interplanetary communications. And again, it's called the bundle protocol. Let's see. We have straight throughs and crossovers. We've talked about it. I feel like everyone has a pretty good grasp. Next week when we're doing labs, we're going to be using the correct cables to cable things up. What is a crossover cable? Don't answer. Don't answer. Crossover cables, yes. A and B, and you connect dissimilar devices? Similar devices. Yeah, so Matt and I were talking about it on Tuesday, like how to remember it. Yeah, it's the opposite, right? Exactly. It's so because it seems counterintuitive. So, if the ends are different, the devices are the same. If the ends are the same, the devices are different. Okay? Let's see. And then what is a rollover cable? It's a console cable. Not that. What is a console cable? Yeah, it's used to connect an end device to an intermediary device. For what purpose? Configuration, right? To configure or to pull information. Okay. Let's see. We talked about fiber. We're going to look at some fiber ends in a minute. How does each cable type transmit information? We know it's either light, electricity, or wavelengths. Right? So that's the signal method. How does wireless fit into a physical layer? That question is being asked because sometimes I think people have a hard time relating to wireless being physical because it's not something you can see, like a fiber optic cable or an Ethernet cable, but it's still media. And then bandwidth, right? So there's 3 different terms in the book, maybe even a couple more. What are the 3 terms that fall under bandwidth, Caesar?
That's like talking about like latency.
Latency? Yeah, latency, throughput, and good put. Now, I think that latency is, you can understand latency, good put. Can somebody explain throughput? What is throughput? Somebody other than Caesar? Lou?
Is it how much data got transferred during a set amount of time?
How much data got transferred? You're on the right track. The measure of the bits. Yeah, and so if we take your answer and kind of combine it, it's the number of bits that are being used. Okay, and I have a little bit better definition. So let me see if I can explain using terms that maybe we've heard of. Has anyone used a VPN before? Okay. And if you use a VPN, have you noticed that it can slow your data down? A little bit? Okay. So the reason is because it takes bits or overhead to build the VPN and hold the VPN open. Now those bits are not being transmitted from the source to the destination all the way through in the form of traffic, but it is bits that are being used as overhead to build the VPN. So that's what throughput is. It's the measurement of all of the bits that are being used in order to make that total conversation happen. Good put takes out overhead, and it's just looking at the actual traffic that's moving all the way from source to destination. Make sense? Okay. What's latency? Yeah, the measurement of it's like a time measurement, right? And versus a bit measurement, right? It's the time that it's taking. Okay, so let's see what else we might need to look at. Transport bits. What is the PDU at the physical layer? Yeah, what is the protocol data unit at the physical layer? Bits, yeah. Okay, don't send pets for beer, right? Don't send pets for beer. Here are the different physical layer standards of just three. Yeah, we've talked about this, the physical components, a NIC card, right? The cable, RJ45s, yada, yada, yada. Encoding and signaling, so we've talked about those things, so we have a pretty good understanding of that. It's all the physical components. I feel like the physical layer is, again, kind of a layer that we interact with more along with the application layer, so the layers on the end, it's easier for us to know a little bit more about because we're interacting with applications, we're turning our computers on, we're plugging cables in, stuff like that. Did we already talk about the way that, did I already tell you how I do the standards stuff? Memorize it at the time? Okay, so there's a lot of standards and organizations that you need to know for like exams. And even in a job, you might need to know one or two standards or one or two organizations that you're dealing with on a regular basis. For a short time, I was reviewing like corporation commission complaints. And so there were some organizations that were involved with that, so I had to be familiar. But for the most part, unless you work for a standards organization or you like maybe work for a fiber optic company that needs you to know the standards for fiber optic, you're not necessarily going to have to know or memorize standards organizations and RFCs, but you have to know them for the CCNA, or you might have to know them if you're taking the CompTIA exam, if you're going to go and be a CCIE. So my recommendation, if you're studying for the CCNA, is that you make a list of things that you know you just have to memorize that you may never use again, right? Except when you're taking the exam, because you don't want to spend a ton of quality study time memorizing these things, but then about 2 weeks before you take the test, start to memorize them. Because then you're not going to necessarily need to know them again, right? So here are the ones that show up on the CCNA often. I've seen a couple of these on the Lennox exams. I've heard that, I have not taken a Lennox exam, but I've heard that Lennox will sometimes challenge you on a couple of these. So the ones that I think are important is the ISO, the International Organization for Standardization, EIA, TIA, a really big standards organization in the field of networking. And if you think about it, all of the internet started through the telecom industry, right? That's how things really got started, is through telecom. The other one is the ITU, again, International Telecommunication Union, right? And how does it show up on a CCNA exam? Sometimes a matching, which are brutal. The matching questions on the CCNA are brutal. I don't know why they're so, I see Chase nodding. They're brutal. I can't explain why they're so hard, but they'll have, again, let's say it was this, EIA, TIA, they'd have the standards organizations, and then they're not gonna say, it ensures the efficient and timely production of standards. It'll give you a scenario. It'll give you like a scenario, and you need to know, like, okay, in this scenario, what standards organization would need to be involved with that? It's not gonna just be, which I think is kind of why the matching questions are so hard. Anyway, yeah, they're terrible. ANSI, the American National Standards Institute, oversees standards and conformity. If we didn't have standards, just imagine, so a lot of, you would maybe remember, yeah. And I think, I don't know, a lot of you might be too young to have experienced this. I don't know for sure, because I don't really know when this all started to change. When we used to have mobile phones, every time you would buy a new mobile phone, you had a totally different charger, right? So do people remember that at a time? So it's like you'd get a new phone and the charger you had, and maybe you had bought 3 chargers that no longer works. Well, a standards organization stepped in and said, that's it. Stop doing that. You cannot keep doing that. And same goes with Ethernet, same goes, again, the iPhone has, and now they've finally been pulled into the standard, right? I think.
Yes, it's the European Union.
Yes.
Down on them about the chargers, so everyone had to go to USB-C, I remember.
And that's because of a standards organization. They just said enough is enough is enough, right? So that's one of the things that these standards organizations do for us. And it's at every level. Okay, I want you to think about, like, how does this apply to the OSI model? It's the same at the network layer. I can't just say, you know what? IPv4 and IPv6 is really cool, but I want IPv12. I'm just going to do IPv12 because I decided I'm going to do that. There's a standards organization that won't let me do that. And so same goes if I want to create a dynamic routing protocol. If I create a dynamic routing protocol, it has to accommodate IPv4 and IPv6. That's what the standard says. So that's what standards do for us. And again, if you could imagine, they work throughout the entire OSI model, okay? IEEE, this is one we really probably do need to know. It affects us in a lot of different ways as network administrators. So if there's something that you learn, I would say it's the IEEE, okay? Because this affects us the most. Those are the ones I think you ought to know and practice. And again, there's two frames of thought. You can just start learning and practicing them now so that you know them, or you could, again, kind of delay it and just memorize them right before the exam. What's the process of converting information into another acceptable form of transmission? Everybody? Encoding. Good job. Good job. And again, what does it look like? We're taking these 1s and 0s, and we're taking an electrical impulse, right? And we're assigning, if the electricity is on, that is a 1. If the electricity is off, that is a 0. This is what it might look like if it's light. We've got light waves. The height is going to be on, the low peak will be off, and then we have sound. We've got our radio waves, okay? We've got that. Method of representing. What are the 3 basic forms of network media? We already know this: copper, fiber, wireless. Okay, so we reviewed this already. Capacity. So Bandwidth, remember, bandwidth is not really a measurement of time. It's a measurement of the number of bits that are moving across time. That's why it's the number of bits per second. It's a measurement of bits. And that's another one. Like, they'll ask you this weird question on the CCNA, and like 3 of the answers will look right, and 2 of them you'll know are wrong. So if you can just remember, it's the measurement of bits. Time is the second piece, right? It's a measurement of bits over time, because they'll word things in very complicated, convoluted ways. 100 megabits is a bigger pipe, more goes through it. 10 megabits is a smaller pipe, less goes through it, right? So I can move more bits through this than I can move through this. So it's not that it's faster from a time perspective. There's more that goes through it. Oops, wait, let's look at that. Bits per second. Okay, yeah, we know that. Okay, latency. Which one of these is latency? Remember, latency is a measurement of time. So which one up there is a measurement of time? Latency? Yeah. So which one is it over here? The measurement of the transfer of bits, the amount of time, the measurement of usable data. Measure of time, right? Remember, latency, it's so late, even if you can just like late, that's a time, right? That's how you can remember it. And then we've got good put. This is the usable data, right? That's a usable data that's from source to destination. Okay, notice what this says. It's minus the traffic overhead, right? That's whatever the overhead is. When you get into 150, we start learning about different types of protocols that have overhead. So like in STP, Spanning Tree Protocol, in Ether channel, there's bits that need to be used in order to communicate with the devices, and that's overhead. Those bits have to be used so they can talk to each other. Those bits aren't being used to move data. The switches are talking to each other, and they're using up some of those bits. And then lastly, our throughput, the measure of the transfer of bits across the media over a given period of time, right? And that should say all of it. You know, it's like a measurement of all of it. What are the 3 different copper types? Let's hear it. The first one, the most common. UTP. What's the STP? Coaxial. Okay, so we got those. Now, what does the twist mean, and what's significant about the twist? Like, what did the book talk about? I think the book talks about the twists. So let me come back to you in just a second. So Lou, what was that? Yeah, the twists, right? That's what the twists are for. And then add to that, Daniel. Yes, and if you look at the different colors, what's significant about the way they're twisted? Exactly. Some of them are twisted more than others because you don't want them to match, because that'll give you crosstalk. Oh, there's that. Yes. Okay. This is for EMI and RFI. There's always a question about EMI and RFI. Chase, did you have a question about EMI and RFI on your CCNA? Oh, maybe not. That's good. Properties. So here's that twisting, right? The cable uses wire pairs to create opposing magnetic fields, which cancel each other out. And then we'll see that the twists are different sizes. Are any of you going to come to the cable making lab? Okay. So that's next week. There's one on Friday. There's one on Saturday. It won't be our only ones. We'll have a couple more throughout the semester. And so when you're doing it, just like look at them. You know, when you take the outer casing off, just look at that so you can see it. And I think I have a couple in here I can maybe pass around. Oh, there's a nice one. Oh, and another center post. I hate these center posts. Okay, so there. EMI and yep, to counter the negative effects, we twist it. Here, when you're making your cables, right? You want to do work on making a good one so that it's properly terminated in the case. These are all the things that you'll get to practice when you're making cables. It's important if you're going to work in networking that you can make a good cable. You just never know when you're going to have to do it. So it is a good thing to practice. Cat 3, never use it. I've never even seen Cat 3. Have you ever seen Cat 3, Jason?
Yeah.
You have?
Yeah.
Where?
All of your telephone equipment.
Oh, okay,
If you're
okay.
going all of
You're
it
right.
on telephones.
Yes. Okay, I'm thinking in the world of data. So nothing, though, in our world.
Nothing
All
in
in telecom, telephony. Okay, yes. Agreed. Cat 5, Cat 5e, this is that page we were looking at earlier. Here's our different speeds. I do recommend memorizing this. And you could tell when we were talking earlier, I didn't really have it, good in my memory. What are the 3 types of UTP cable? And the N standards. Well, we have A's and B's. So what if you have 2 A's? Straight through. If you have an A and a B. And then what's the third kind? A rollover. So this is what these colors are doing. This is like what their job is. So the first, when we have the white, green, and the green, these are receivers. They split the oranges. Which are the senders. In the middle are the DC power, which really isn't used unless you're doing like power over Ethernet, which we don't use, okay? And then down here, we also do not use these unless we're using gigs, like the gig speed. So for the most part, what's really doing the work on these T568As and Bs is the 1, 2, 3, and the 6. That's what's doing the work, okay? That's what's doing the work. Always grow oranges by the berms. That's how I used to remember it. Now I just remember it, right? And then B, oranges grow by berms. All right, here's our rollover cable. Just rolls over. Let's take a look at some cables. So let's look at some cables. I'll pass them around. So we've already passed the shielded twisted pair around, right? So here's another one. Here's a nice piece of UTP. This is a good piece of UTP because some UTP, it's so cheap that the sheathing isn't on tight. And it's hard to make cables. This is actually kind of a nice one. Some of the blue ones, it's like kind of a looser sheathing. Can you tell by looking at the color what kind of cable it is? Like what is this? What is this? Is this going to be a crossover or a straight through? No idea, right? No idea. Okay, but if I come in here and I see that this end starts with an orange, what is the end? A B, yes. And then if I look at this end and I see that it starts with an orange, I have a T568B straight through. I have a T568B straight through. Okay, so let's see here. I'll pass a couple of these out. Okay, what's that?
The rollover.
That's a rollover. Here, let's take a look at a couple. Let's pass one down. There's 2. Pass them down. Here's one. Just take a look and just look at it and see if you can tell what they are. Make sure you can tell. Now, you can look at the clip side or the flat side. Some of them show up better on one side or the other, okay? And also, if the orange and the brown can sometimes look alike, so that's another thing. And if there are, there's a lot of technicians that are colorblind or have color weakness where they can tell color, but not if it's not as strong enough. We used to work with technicians that had that trouble. So, sometimes they had to just kind of start to figure out the shade, of gray that it would be for their eyesight can be problematic. Yeah, wherever, just take a look, and just, I am pretty much in the habit now. I mean, Here, I know that our blue cables are straight throughs, but whenever I'm doing anything, I just look. Because I just don't ever want to rely on something being crossover or straight through.
How do you tell again which side is the one, the side that has the push button?
So it can vary, but usually it's the flat side. So like on this one, I'm looking at the flat side and I can see that it starts with orange. Now, even if you look at the clip side, you're just kind of looking at it from right to left then.
Look at both ends the same way.
Just look at both ends the same way, yeah. As long as you're looking at both ends the same way. So like here, I'm going to look at it this way because it's easier. So I find it easier on most of them to look at the flat side. So this one starts with a green. So what is it? T568A. This one starts with an orange. B, so it is it's a crossover. It's a crossover, okay? What is a loop back? A loop back is an interface. A loop back is an interface.
It's also a cord. You can physically wire a loop back.
Oh yeah, you can, especially on a fiber. So one of the reasons that we start talking about a default gateway in this module is because there's a lot of things related to the physical layer that relate back to the term default gateway. Okay, the term default gateway, so remember what we talked about? So there's three things that describe a default gateway. So raise your hand and give me one. Okay, Brody. The interface on the router, and give me one more piece of that. Exactly, interface on the router, and it faces the LAN, right? It faces the LAN. So look at this, here's our router, and let's say that this is our interface, right? So here's our interface. What layer is that? Yeah, it's the physical layer, right? So an interface, that's layer 1, the physical layer. Now I'm going to plug a cable into it. What layer is the cable? That's the physical layer, right? That's the physical layer. Okay, now chances are I might plug that into a switch which goes into the port. What layer is that? The physical layer, right? And then maybe I've got a computer that plugs into the NIC card. What layer is that? Physical layer, right? So that's why we start talking about a default gateway early on. And not only that, now this is called a what? So anything from this interface that's attached is what? It's our, what kind of a network? A local area network. What layer does a local area network work at? Not the physical layer. The data link layer, layer 2. So they work together. They all go together, okay? So this is a local area network works at the data link layer, okay? It works at the data link layer. All right, so we have an interface on the router that faces the LAN. What's the second thing? Okay, so it's the exit and the entry point for the network, right? For the local area network. And then what is the other one? And what about that IP address? It probably is the first usable. Does it have to be? It does not have to be the first usable. It makes the most sense, but it doesn't have to be. But what else? It has an IP address. It has an IP address. I need a little bit more. From the LAN. From the local area network. This IP address is going to be from the same network as any of your devices. Okay? Got it? So next week, when you get a quiz on those three things, you're going to know those three things, right? Without notes. Okay. Can I erase that? Yes? Okay. So with fiber optic, mostly what I want to do is I just want to review the connectors. Fiber optic, what are the two types of fiber optic? Single mode and multi-mode. What's the difference between them, Matt?
Multi-mode is 2 ways, and single is one direction.
And what about speed? Distance? Yeah, so single mode lets us go much further than multi-mode. Single mode is known to go a little faster because the core is smaller, right? So it can push it through. I mean, it's minuscule, but it's a little bit more efficient. It's a little bit more efficient than multi-mode. And then what about like colors? What color does the orange represent? So this would be single mode, and this would be multi-mode, right? Okay, and then let's look at some connectors. What are the different types of connectors? So we've got SC connectors. We have LC connectors. ST. Did it talk about SFPs? It did? Okay. And then I think, did it also talk about like duplex LCs? Okay. So let's like take a look, and I think I have examples of a few different kind, and I'll see if I can tell you how I kind of remember them. No EMI. Single mode uses what kind of light? Laser, and then multi-mode? LED. I think you could use a laser with multi-mode, but you can't use an LED with single mode. Okay. Let's see. All right, so if we look at the different connector types, let's look at that. So for multi-mode, okay, we can use straight tips or STs. That's how I remember them. ST, straight tip, because they have a longer tip. They all have straight tips, okay? But with STs, you can see the tip. Okay, it comes out further. It comes out further. And again, they're the most common. And let me see if I have an example of an ST. Well, actually, these are STs. So let me find another one. So that's not coming off. I'm sure I have one. That's not. Oh, there, I see one. That's not one either. There's one. Okay. It's kind of tangled up in here. So again, just a straight tip. It looks a lot like a coaxial cable. And it's kind of hard to see, but if you look right in there, you can actually see the core. You can see the glass on there. And they polish the whole top of it. So that's an ST. They usually come with caps. The caps are just to protect them from dirt, mostly, right? And they can be breakable. So that's the ST. And then for what will work for multi-mode and single mode is the LC, and you can have a duplex or a single. It stands for Lucent. Lucent is a company that designed it, okay? But you can also remember it as like it's a little connector or a little clip, because they have little clips on them. Here's one. So it's little, and see how it has this little clip? So it has a little clip. That's how I remember it, by, I think, oh, little clip. So, and then I think I have a duplex. Yeah, so I have a duplex here with a little clip, a patch cable. This is a duplex because it's got 2, right? But it's got the clip. So LC, little clip, can be used for multi-mode or single mode. Okay, multi-mode or single mode. And then we've got some for single mode. Oh, there's our duplex little clip. There's another simplex little clip. And then for our single modes, you can have SCs and LCs. So this connector, it snaps in place, right? So you can snap it, and it, I think I have some of these too. And I can, oh yeah, here's a nice snapped one. I have that attached to my flux capacitor. Oh, here's some. I do too, yeah, square connector. Again, however you need to remember them, but they're square, but they do snap in. So you can also, again, that's why I think of it as a snap. They snap in. So I'll pass a couple of these around so you can look at them. Oh, this is like a patch cable. So I can connect the snap with the straight through, right? Snap with the straight through. Let's see if I can get this undone. They're all tangled up. So see this tangled mess? That's the worst thing for fiber, because that's pretty much the only thing that will, now these are so small that it might be okay, but a bend radius, because the light has trouble bending, you know, going around bends. Okay, it has trouble going around bends, but here's, again, just pass it like that. You can't break it, it's already broken. You know. Yeah, they're too tight. So it's a good idea, again, to memorize those connectors. They've been on, again, they're on a lot of the different CCNAs. Nobody ever gets the same CCNA, okay? And so, but there's commonalities, and I haven't taken a CCNA in a couple of years, and so I can't tell you for sure, but I have students that will say, oh, I had like 12 wireless questions, I had 2 fiber connector questions. And on the CCNA, they usually have what are called test questions, which are questions that are not going to count against your points, but they're testing them. They're seeing what students know about them. They're gauging whether or not they need to add more content to the class. They're gauging whether or not they need to add them in as questions to the test. So many years ago, we had a lot of fiber questions in the test questions, like the practice ones. Then we started seeing them on the actual test. So.
I have some fiber questions on my CCNA.
You had lots of fiber questions?
I had like a couple, not long.
Yeah. Again, you think about it, there's about 90 questions on the new CCNA, and they have to ask you questions over a broad range of materials. So you might only see 2 questions about a topic. And so that's why in every question, you have to know multiple things in order to answer that question, because they are, what was the example that we used earlier? So it would say something like, oh, if the low voltage is considered a 1 and the high voltage, no, the low voltage is considered a 0 and high voltage is considered 1, you know, how would the media be responding or something? So you need to be able to translate that to, okay, what are we even talking about? Oh, okay, something on the OSI layer, the physical layer. So you have to be able to answer that question first. Then if you know that, it's like, do you know anything about encoding? Because what they're talking about is encoding. Oh, and now what I know is they're talking about the Manchester method, right? So you have to be able to answer multiple things in order to get to the final answer. Does that make sense? How they're doing that?
It's 2 tests, and I think they're 9 years.
There's 1 test.
For A plus?
Oh, for A plus. For A plus. Yes. Yes. Yeah. I don't know if you get 90 minutes. I'm not sure what the time is right now. Because they've changed it. You used to have two, kind of like the CompTIA, there used to be 2 exams for the CCNA. Now there's 1. So double the questions. Yeah, it's for sure time. And it's not, when you've answered one question, you can't go back. That's it. You've moved past that. All right, are there questions about these connectors? And did you take notes about it? We don't. We really just can't afford it. Yeah, we really just can't afford it to do fiber. It's, and we've had companies like offer to donate the fiber cables, but we still need what are called the Bixies, which is what the fiber plugs into. So even if I can get fiber cable,
And those are the most expensive parts.
exactly. It's the Bixies that plug into the port that the cable plugs into. So, it's just, and not only that, the testing. So buying an OTDR, which is a fiber tester, I mean, like the least expensive fiber tester, which is a modest one, maybe, not that great, is probably like $350. Yeah, but I mean, and that's what you really need, right? We might be able to get one for $350, like a used one or one that doesn't test everything. And then you have to have the cleaning tools. There's like a cleaning tool and a polishing tool and a splicing tool. It's just not realistic for us. It's not realistic for us. And frankly, again, we could buy a cheap enough cable. It's everything else that is the problem. Okay, so there's again our square connector or our clip, right? Patch. And then again, if we look at these patch cords, what the patch cords allow us to do is connect 2 different types of ends. Orange is what? Multi-mode. Yellow, single mode. Again, I think another question you might need to know, and again, how would the question be? It's like, you need to, connect an LC to an ST, and you're testing a long haul. You're testing a long haul connection. What type of a patch panel? What type of a patch cable would you use? It's a long haul. I would need to use a single mode, a yellow single mode patch cable, right? So they're going to give you this information, and then you have to figure it out based on that. And they're going to add things like, you'd use a serial cable, you'd use a rollover cable, you'd use a patch through panel cable, you'd use this and this and this, and you need to know that. There's our different patch cables, yellow jacket, okay. And this, again, a memorization, read it and memorize basically what the speeds are that it'll take you. Okay, let's take a break. It's 8:27, let's come back at 8:35. Okay, and then we'll finish up class with a few Kahoots and a couple of other things. $8:35. You didn't send it. Okay, so let me take a look at it. Did we go over these in class? Did we already grade them together in class? I don't remember. Do you remember if we went over them? Okay. I just don't remember. But I had everybody mark it, right? Okay. And this was Tuesday. More practice. Did anybody else bring their more practice in that didn't turn it in on Tuesday, that they wanted to get it in today? Thank you. I'm going to give it back to you. Okay. Let me see. So, Oracle, go in there and mark it now, okay? Or wait, not yet, because I haven't hit save. Just a second. Let me add the other. Anyone else? Thank you. Anyone else that didn't turn it in Tuesday that wants to turn it in today? Okay. All right. So I reopened it. If you go in there, you'll be able to, oh wait, I might have to add another attempt. Let me do one more thing, because you might not be able to do another attempt because we had turned it in. Okay, there's that. So that will work. And okay. Okay, now I think it will work now. Do I have all the fiber cable? Oh, let me have that little batch of fiber. Thank you. I think you need to know the speed that fiber will go.
I think there is a question on that one.
Yeah, I think there was.
That sounds familiar.
You can just go in that second
That was one
cabinet.
definitely not one.
In that second cabinet. I'll be back. Okay. I want to finish up with wireless. Okay. Like I said before, there's a lot of wireless on the CCNA. Wireless is, I've never actually, when I was out in the field, I didn't do very much with wireless. It's one of the things that I am the weakest at as far as just general knowledge and being able to do. I think that there's a lot of wireless on the CCNA because there's just a lot of things happening with wireless right now. Now, we actually do spend more time in 150 covering wireless. In 140, they are more or less introducing it. And again, I think some of it is memorization type stuff, so I don't see the importance of us going into a deep conversation about it, A, because a lot of it's memorization, B, because we're going to go over it in 150, for those of you that are going into 150. It is important to know what the frequencies are, and this is something we work with in our lives. If you have a wireless router at home, chances are your wireless router can either do 2.4 or 5. Most of them do now. Most of them are dual frequency. You need to know which of the standard works with which. So you have 802.11, BGN, and AX, and these are backwards compatible. So if you have an AX, it would be backwards compatible with that. And then if we have a 5 gigahertz, it's 802.11. The standards would be AN, AC, and AX. This standard was created by the IEEE. It's important to know that. You probably also need to know like WPAN, maybe Zigbee, WiMAX. So you want to know what those standards are, the 802.15s, the 802.16s. And then, again, just memorize them. In 150, I'll go over, again, I have a mnemonic for everything. Always bring girls new accessories. So, that'll help you remember A, B, G, N, A, AC, right? So that will help. These are the ones, and they are capable of different speeds. Only some of them are backwards compatible with each other. So 2.4 with 2.4, 5 with 5. So again, this is stuff, it is just rote memorization, and so it's not the easiest thing unless you love memorization. Let's see. These are just some different ways that I've memorized them. And there is a new standard that has been created by the Wi-Fi Alliance. And it's so much easier. The problem is IEEE is not adopting it. And so this is a new naming structure, which is just like Wi-Fi 6E, Wi-Fi 6, Wi-Fi 5, Wi-Fi 4. So this is our older, and they're going to just keep going up from here. It's so much easier to memorize and so much easier to think about. But again, you really can't rely on that because the IEEE hasn't adopted it. And as of yet, they say they're not going to. So, What's that? YWIG? Mm-hmm. Okay. I want to review what the next thing is. We're going into module 2, okay? So we did 5, we did 1, we did 3, we did 4, and now we're going to do 2. So now that we kind of know a little bit more about cabling, we've had a little time to immerse in the class, you've done some packet tracers, I think it's a better time to do labs now versus like week 1, right? Because week 1, when we're trying to get you in there, is like, what? I don't know anything. Now it's like you know a little bit more. So next week, we're going to start doing labs, and it will be so we can start practicing using the cables, plugging things into the devices, creating networks, doing your IP addresses, and practicing the commands, okay? So module 2 is all about the commands and the structure of the commands and the different modes as you move through the device, okay? So like user mode, privilege mode, global mode. The requirement for the flashcards is fewer because it's mostly commands. There's not a lot of like foundational knowledge about something or conceptual knowledge. It's this command does this. This is why you do that. That's the type of thing you want to pay attention to. It's also important to understand what the startup configuration is and what the running configuration is, okay? So when you're reading that, you want to pay close attention and make sure you're getting notes. It's really important as it relates to the operating systems, to the storage, and to the way that your devices are going to put out information. So you want to know what are the components of the operating system. So our computers have an operating system, well, so do our routers and switches. Okay, they're working on the Cisco operating system. What is the difference between in-band and out-of-band? Well, we talked about that, right? We talked about that this week on Tuesday. So you want to just revisit that and make sure you understand. If you're in-band, that's when you've built a little network, because next week we're going to build networks. And you're going to access that network with an out-of-band connection. Why do you need a console connection? What are the basic CLI commands? What are the modes? User privileged global. How can I use the help feature? Okay, so they have a help feature inside the operating system. Are there any basic security commands? What are they? What's the difference between the running config and a startup config? How do I put the running configuration into the startup configuration? Again, so you want to make sure that you can answer, well, what's a startup configuration? What's a running configuration? Why do you put the running configuration into the startup, right? And your answer, not the book answer, okay? Because the book answer is going to sound like a bunch of Wikipedia garbly-goop. Put it in your answer so that you know what it is. What happens if I don't put the running config into the startup? And then what's the significance of an SVI? So we're going to start talking about something called a switch virtual interface. It is about a virtual interface, something that doesn't physically exist on your device. And it plays a really important role in managing our devices. So it's important to start practicing and learning what that is now. And we'll be using that through all of the Cisco classes. And that's true for any device that you use. It's not just Cisco devices. It would be any device. You're going to have some sort of a way to get into it. Okay? All right. Any questions about Module 2? All right. So again, next week, I believe we're doing a lab on both days. So just come prepared, because the labs shouldn't take the whole class period, so we'll do some other stuff, but they might. It just depends. Okay, we're going to do a smorgasbord. So this is a smorgasbord Kahoot. We have now completed modules 1, 3, 4, and 5. So this will be a smorgasbord. Oh, I thought I hit the start key. Everyone's looking at me. I'm like, why is everyone looking at me? Oh, I hit the start key. What?
A couple people over here said, oh, I hit the wrong one.
0 and 8 for the 168,
Yep, 168. A wide area network, a WAN, a WAN. Well, that's what makes it so sneaky is he doesn't look that malicious. What's an insider threat?
Zombies if they're in the house.
If they're in the house, that is true. In 150, we do a troubleshooter about a malicious employee called a gremlin. Oh, what happened? So let's do the layers. Layer 1, 2, 3, 4, 5, 6, 7. Okay, so what layer are their port numbers? Transport layer. Where are MAC addresses? Data link. Where are dialogues? Session. Where are conversations? It can't be session 2. Dialogues are at session. What's at the transport layer? Conversations. Conversations. Where does encoding happen? Physical layer. Physical layer. Where would I find an MP3? Presentation. Oh, did I hand that? Did we do that? Did we hand out the word search where you filled in the answers? Yeah. Did I collect them? Oh. But we didn't go over them. Okay, hold on. I got to make myself a note so that we go over them next week. Go over. Go over word search. Okay. All right. I had to add a note. All right. Good job. Ooh. Oh, I can. So both IANA and ICANN do, they are standards organizations related to IP address allocation. We'll talk more about it when we talk about the network layer because they work together. can't believe anybody missed that. We've reviewed it a lot.
I heard it crash, so I know someone didn't intend to.
They hit it accidentally. Oh, I need to order mice. What are those mice for? The laptops? Were they in there?
Yep.
All of those were in there?
Yep.
Can we put them in the cabinet?
If that's where you want them. Yep.
Yeah, I don't know why they're in there. Why are those in there?
No clue.
I don't want them in my drawer. Maybe we can find a plastic thing to put them in. And then a label. You know, I like things labeled. So an A and a B. So a router to a PC, right? What is an A and a B? What kind of cable? A crossover cable. And a router and a PC have similar brains, similar network cards, right? Look inside that cabinet, Chase. There might be some of those flat ones. I can see through metal. Yikes. A most popular type of connector. Straight tip. It's the very first one we talked about. Straight tip. Ow. That's an A, right? Yeah, no, it's an A. Oh boy.
Boy, that is so vague.
Nope, but that's what it says in Module 1. So 10.10, so the 26, first of all, what octet are we in? Fourth octet, and a 26 increments by what? 64. So if you add 64 to the fourth octet, you get 10.10.0.64. Angel, Gabby, second time. Good job. Jason, outstanding. Runners up, Kaiser, DB, Daniel. Okay, so if you missed some of those, make sure you know why. Okay, and you may have to review some stuff, you know. You might have to, if you didn't do good on the hexadecimal, consider reviewing it. All right, make sure you do a good job on Module 2. I just published one last assignment to get yourself out of here, an exit assignment. It's the matching. Do you know your media? Do you know your media? So if you refresh your screen, you're going to see that. And if you don't know your media, know it by Tuesday. Yes.
Well, we don't need to do that in the future.
Yes, and I have a package in my office.
Okay, it's the same back.
Okay. When you're done, you're free to go. Marcus, do a little more homework this week. Just pop yourself up into the C's.
Okay.
Right? That won't take many things. Like it won't show right away, but if you pull mind maps, all of those done, again, it won't change your grade right away till we grade it, but it'll put you at 7.
Sure do this.
Okay, thank you. night.
Well, actually, he accidentally clicked retry.
How do I click one off when I don't want it?
How do you click off?
Well, I'm trying to change that. I don't want.
Oh, I don't think there's a way to do it, but I don't know.
Okay, well, I guess that's what
If there is a way to do it, I don't know how. There, did you scroll up? Yeah.
I got it right.
Yes.
I accidentally clicked retry on here.
Okay.
Do I have to redo it again?
We're
Or?
supposed to put in there, or just the band?
It'll like
Like
you
I-
already have one done.
Yeah, like I finished it. And it
I
gave me,
don't
like, the
think
thing.
so. It'll keep your highest score.
Oh, okay, cool.
If you want to practice though.
I have a minute left.
Chase, do you by chance know what brand those new laptops are?
I can go look for them.
Would you? They're in 109.
Yep. There's in 112.
Oh, they need to be moved back to 109.
Okay.
When can you let Greg know that at the end of class they?
Chris not in there. Chris is in there tonight.
Oh, Chris is in there. Okay, Chris knows. But yeah, we just need to make sure they're in 109. We can't leave them in another department's room. Yes, Lou.
I got a question about the packet tracer.
Yes.
There was one of them that was just, there was no percentage. Do I just put 100?
Which one? Put in 100%. Which one was it? Do you remember? Because I'm trying to fix all those
Oh, it was in the middle. It was the second.
in module 4.
Yeah.
Was it 471, like the one that tells you more like, oh, watch this packet?
No, it was more like how to ping the network and then do it on your own computer. And it was like that.
Okay, let me, because
See
I'm,
the module I could point it out.
okay, yeah, let's look at it. Because I'm trying to kind of like fix those little one-off ones so that it's not confusing. But whenever that happens, just mark 100%.
Okay.
Yeah. Somebody else asked me about 4.7.1, but 4.7.1 actually did give a percentage.
Right.
It's just that you did not, like there wasn't really that much, you know, you weren't doing anything.
Connect all the cables or connect them
Let's see.
across the matching cable.
Connect the crossovers, and, okay. Packet tracer.
They were Dells.
Dells, okay. So 465, 471,
Exploration.
exploration.
Yeah, that's the one that you didn't do much. That was.
471. I'm not in the VM, so I can't open it. Physical layer exploration. Okay. And I actually, that's the one that someone else asked me about. And so I did go in there to modify it, but it won't affect our class. It'll be the future classes. So yeah, just mark 100%.
All right. That's
Okay.
what I wanna make sure.
Okay. Hey.
Just wanted to follow this, what I texted
Yeah.
you earlier, 'cause when I get 40 out of 40 on my cards, and I get 34 out of 40
Well,
on there, it's the same thing I have on cards.
yes, but the cards are different. I mean,
I make my cards and my mind maps are pretty much the
so we expect the mind maps to be more detailed. And the flashcards are like a snippet of your mind maps. And so on your mind maps, the reason you're not getting 40 points is because you're
Well, I'm just saying
basically,
that they're telling me I got B work on my mind maps and I've got A work on my note cards.
that's because
what I'm
we
trying
don't
to-
have the same level of, we're not.
But it's not even an A, I mean, it's,
That's because you're just answering the important objectives without adding additional
so you
information.
wanted additional information. I'm already spending hours on this and now you want additional information. I'm doing my note cards and my mind maps,
Mm-hmm.
so now you want more information to get an A.
Or maybe the way that you're capturing the information. You might want to think about the way you're capturing
Well,
the
I'm trying to figure out
information.
what I need to
Yeah,
do
I'm gonna
with
I'm
this,
gonna show you an example.
Okay.
I'm gonna show you an example. So let's see. Mind map is thoughtfully structured, captures the essence of the topics covered in the module. So I think partly you're just capturing the important objectives, utilizing your own words. I would say that you're using a lot of your own words, not all your own words. Under demonstrating an important objective, sometimes when you use words straight from the book, we can't tell if you're understanding that. Demonstrates creativity through the use of colors, images, and layout. So you're always using text, no images, no snips from the book or snips from outside resources. So that's because I think you have a text-heavy mind map. So I will show you. Let me see if I can see who's getting. A lot of times. Let's see, that's not a good. He has had, this last one I think was really good. Are you turning them in late at all? Because that'll subtract some points too. Okay.
Well, the one that, there was one in here that you said you were gonna adjust it, but I don't know if it got adjusted.
When did you turn it in?
Well, you said everything before Sunday was gonna be adjusted, and I only turned it in.
Not this Sunday, that was,
The last module, I only turned it in one day late.
so the Sunday of the
Okay,
31st.
So we had an assignment, when we first came in for the first week and nobody had done their note cards.
Yeah.
You changed it to Tuesday. I didn't get my stuff done till
Oh.
Wednesday that following week. But you
And
said
did
it
I
was still-
change the date? Did I change it?
I don't know. You
Oh,
said you
take
were
a
gonna
look.
adjust
I
everything.
did. I mean, I did
don't know
unless
if the
I
score
missed
changed.
something.
I don't know if the score changed, that's what I'm trying to say.
Oh, take a look at it. Oh, you're not sure if the late penalty is applied. Okay,
Correct.
I got it. I can look at it, but I did take the late penalty off. I mean, assuming I caught them all.
Yeah, maybe seeing a couple examples of people that got A's would help me figure out what I need
And
to do more of.
we're working on doing like an example.
Well,
So here's an example of someone who's capturing the information, adding some different content that isn't as text heavy. This person did get 40 points, as Brody. His have been pretty good. And then he's breaking stuff down. He does have notes on some things, and so we can read that the notes are in his own words. And I would say that's the primary thing.
yeah, I'm not sure I'm willing to do the extra work for that.
Well, again, that's what is a not.
All I care about is getting a good grade and making sure I know the information.
Well, and that's what a
Not showing that I know it to you, that's okay with me.
and that's what a knocked it out of the park is.
Yeah, that's
A
okay.
knocked it out of the park,
I don't-
and you have a good grade.
irritates me.
Okay, well,
I mean, it's like, my note cards, I still have those from E+. I still use those.
good.
I probably won't use my maps after this class, but I'll use my note cards.
Okay.
So it just tells you what's important to me, I guess, is
Okay.
having a good mind map or having good note cards. Note cards are more important to me.
So then I think you're spending your time wisely.
Right, I'm just saying, I don't know if it's worth it to me to spend the extra time.
I would agree with you, especially because
It's
you have
like,
a
I just
very
thought- well, I am
you
a
have a
95 word, but I just,
you
know,
have
I
a
mean,
very good grade in this
I'm a
class.
perfectionist. I want it as high as I
Okay.
can get it. Yeah.
Well, then if you
that's
have
just
to
my
have an
fault,
A, if
yeah.
you're a point chaser,
Yeah.
okay, if
No, I mean,
you want to chase the points, then that's what we're looking for, okay?
Right, yeah.
And I can't change my grading parameters
I'm not asking you to change
because
your grade,
of,
I'm
you
asking
know.
what I can do to
Yeah,
get better. That's
right.
what I was
But
asking.
I'm telling you, your mind maps are
I
good.
just need to add more to them.
If you're going to chase the points, then you're going to have to add to them. I would agree with you. If you think that the flashcards are your best study guide,
Right.
it might not be worth it for you. You're going to get an A in the class.
Right.
So that's what you need to decide.
Right, okay, okay.
And then don't be mad about it.
I'm not mad at it, I'm frustrated.
Okay.
Never mad, just frustrated.
Yeah.